Hi, good evening, good afternoon, good morning. I don't know, what time is it over there for you? Either way, thanks for stopping by. Today we are going to talk about the diminishing resources and deteriorating environmental conditions on our planet. This is going to be the second part in our little mini series. Today we're going to be focusing on heat. And if you haven't seen it, this is going to be the smaller video about the larger video on global warming, climate change, and environmental pollution, a recipe for a multifactorial stress combination disaster. This paper here is the backbone for essentially the entire video, and it is by authors Sarah Zandalinas, Felix Versicci, and Ron Mittler. And I am so deeply sorry. I just have this funny inkling suspicion that I have mispronounced your names. I'm so sorry. But with that, let's move on to heat. Okay, so I know I keep talking about global temperatures. Let's now talk about it and why it's important. Remember in figure 1a, it showed what seemed to be an arbitrary 0 point. Where exactly did they get that 0 from anyways? Well, in this figure here, it is showing 5 different temperature recording systems for the past 150 years or so. And as we can see, they're all saying basically the same exact thing, right? Between 1850 and 1900, we can see all the temperatures relatively stayed at this line. This is what's known as the zero line or the pre-industrial line. It serves as a 0 point for climate policies. This is because after this point, before this temperature average, we can see that there was a slight dipping point, but then it exponentially increased. Again, here is fully where World War I stands. We increase. World War II is roughly right here. Decrease just a little bit. And then we really heavily use fossil fuels right here. And it has only gone up. So by definition, as it's getting hotter, this is what is known as global warming, or the steady increase in global average surface temperatures both on land and sea. As we stated in the last slide, governments from around the world have noticed this and have tried to address this issue. One of the many things they have done is create an international treaty to try to keep temperatures below 2 degrees Celsius, or idealistically 1.5 degrees Celsius. And this is known as the Paris Agreement, which was signed in 2016 by roughly 195 countries. Unfortunately, due to the Trump administration on January 27th, 2026, the US will withdraw from the Paris Agreement again for the second time. And that's what this second figure is showing us here. As of January 1st, 2025, all of these countries on green have signed and ratified, meaning they've put in some type of pledge and some type of law changes. These countries here have signed it, and the US is trying to quit it. Again, remember, the US is the second biggest polluting country in the world. So to say that this will affect many future generations and life on the planet dramatically and drastically is a vast, vast understatement. We are accelerating to the point of no return by decades in a span of a few years because of this decision. The regulations and deregulations of the US under the current administration is going to be dramatic. The rest of these slides in this section will explain some of the effects heating of the planet will cause. In climate science, there is what is known as environmental tipping points. These are critical thresholds in Earth systems where small changes can trigger large, abrupt, and often irreversible shifts with significant consequences for the ecosystem and human societies. In this graph, we can see some of the major environmental tipping points as global temperatures go up. This is here on temperatures, global temperatures, as they go up from that 0 point that we've talked about. As the temperatures go up, the more likely it is for these tipping points to occur. And this is illustrated by the different color gradients. So as the temperature goes up, the more likely, or the darker red, these events are going to occur. And some of these events on here are the coral reefs dying off, the West Atlantic ice sheet collapse, subpolar gyri overturning collapse, mountain glaciers retreat, the Atlantic Madrino overturning circulation collapse, the Amazon rainforest dieback. These are all major events. And we can see it's predicted between 1 degrees and 1.5 degrees that this will occur. That's how you read this figure. On this one, it says between 1 and 3 degrees Celsius. It's indicating that This bar might shift downwards if the models were too stable and didn't account for everything. Again, this one's saying this will lower with additional deforestation. It's more likely to occur as we have less Amazon rainforest to begin with. One of the main reasons global policies is trying to stay below 2 degrees Celsius is because once we hit 3 degrees Celsius, it's predicted that 3 major environmental tipping points are going to occur at the exact same time, or if not within a couple of years of each other. And so we've hit this 2 degrees Celsius point to try to stay within the bounds of these other events not occurring. However, as of October 2025, we reach our first environmental tipping point, and that is the collapse of coral reefs, where nearly 80% of them have already collapsed. Corals, which are the backbone of coral reefs, are a very sensitive organism, meaning they have a very small window of environmental conditions in which they can live in. If the ocean warms by even just 1 degree Celsius, they start to bleach, and as they hit 1.5, they are starting to die. And this is what's happening in the oceans as it's getting hotter. And you can think of coral reefs as the tropical jungle of the oceans, where coral reefs support an extraordinary level of marine biodiversity, providing habitat for nearly 25% of all marine species, despite them covering less than 1% of the ocean floor. In this image here, we can see what coral reefs are meant to look like. There's diversity across all reefs, but similarities of very diverse, a bunch of different colors, a lot of different fish, a lot of different types of species that live here. And this is what we're seeing now today is one, they're bleached, but then two, they're dying, and we can see that there's just no life here. And that's simply because the ocean has gotten hotter. Besides these places providing spaces for marine species to live and thrive, they also provide some of these other benefits, as they act as natural breakwaters, reducing the effect of wave energy and erosion, and lowering the number of people affected by flooding by 45%. They provide a natural food source for millions of people. They provide many natural bioactive compounds sought out by medical institutions, meaning they provide molecules that are already readily available, ready for your body to use for medical purposes. They also have a significant impact on cultures and religions. They provide for local and global economies, accounting for a little over 15% of the global economic system, and many, many other benefits that we now are losing and have lost because of rising global ocean temperatures. Many of you have seen or felt the effects of global warming already, whether it be in the form of polar vortexes or seeing northern lights in locations where they haven't historically been in millions of years, or through extreme heavy precipitation or stronger storms or even drier and longer droughts. This is because as the planet gets warmer, it causes a redistribution of the water cycle, making drier places drier and wetter places wetter. This also causes extreme weather events to occur stronger and more frequently. Extreme weather patterns are unusual, severe, or unseasonal weather events that fall at the extremes of the region's historic climate distribution. And in this figure, we can see how global warming has affected these specific extreme weather events. For example, a warmer atmosphere means more energy for storms. Storms then are projected to become more frequent and stronger. It is also causing more rain and snow to fall in heavy and intense quantities. Extreme rainfall has increased flood risk. At the same time, it is causing heat waves to become more frequent, hotter, and last longer. And in figure 1b of the paper, as we can see here, we are seeing the number of droughts that are occurring and the number of extreme temperature events that are occurring. Again, across time, we're seeing the same exponential increase that we've seen in CO2 concentration and global surface temperatures. Another vitally important system affecting global and local weather patterns is what is known as thermocycling circulation, which is the movement of oceanic warm and cold water over the entire globe. It is driven by surface heat and freshwater fluxes. The THC provides circulation of nutrients and stabilizes global weather patterns. Down below, we can see the entire THC, where the red indicates warmer surface water and the blue indicates deeper, colder ocean water. You can think of this movement as a conveyor belt, moving again nutrients and water. On this conveyor belt, there are 3 different exchange sites, one occurring here in the Pacific Ocean, where deep water rises, it circulates to the top, becomes warm water, and moves this way along the current. Over here in the Indian Ocean, it starts in the Southern Ocean, moves its way towards Africa and towards India, in between Madagascar, where the deeper water then becomes the surface, it becomes warmer water, and continues along this route. And again, in the warmer waters from the very tips of the Southern Ocean, move its way towards into the Atlantic Ocean, moves its way towards the Atlantic coast of both the North and South and Central Americas. Then it makes its way towards Europe, just on the west side of the UK, the southern side of Iceland and Greenland, where the water, instead of going up, it goes down because it's surface hot water. It comes cooled, and the water then flows down and circulates down into the Southern Ocean. And this is when it continues its loop, and this again is the entire THC. And in this part of the conveyor belt around Greenland and Iceland, in the northwest parts of Europe, it is known as the Atlantic Madrinal Overturning Circulation, or the AMOC, which we saw in the previous slide. And in this figure here, it's a very complex figure, we can see overall it is telling us that the AMOC is weakening because the ocean water is getting warmer, meaning this part of the conveyor belt is not able to complete and do its entire cycle. And again, as ocean temperatures continue to rise, the likelihood of the AMOC collapsing also increases. Oh, by the way, once the collapse occurs, it would take thousands of years to fix itself. And luckily for us, it is predicted to occur in our lifetimes. It's estimated to occur between 2055 and 2069 if we don't do anything about it. And to put this into perspective of how important the system is, if AMOC were to collapse, here are some of the things that are guaranteed to occur. First, it would keep cooler waters in the north here, which would cause several cascading effects. The first of which would dramatically lower the average temperatures here in Europe. Then soon after, it would be very likely that the ice sheet itself that stays here would extend its way down until around this area, again, this mid area here. So we'd have an ice sheet here, likely causing another ice age, as well as causing permanent La Nina years in this region. This also would cause sea levels to rise and flooding to occur all along the Atlantic coast. This collapse would also, the equator is roughly right here, also known as the tropical region, would move southward because of the frigid temperatures up in the north. This would cause the seasons to change 180 degrees as well. And so much more would happen because of this collapse. Okay, at the same time that all of this is happening and all of this is occurring, we are also seeing a dramatic loss of glaciers worldwide. And this reason is actually pretty straightforward. That is because glaciers are a dense body of frozen fresh water in the form of ice that moves downhill underneath its own weight. Glaciers are formed by continuous snowfall that eventually packs itself down into ice. There are a couple different types of glaciers, and some people might get this confused because they're very similar. I was confused when I was looking into it, but ice sheets are dome-shaped glaciers that cover 50,000 square kilometers or more over land and move in all directions. Similarly, ice caps are dome-shaped glaciers that cover less than 50 square kilometers and still move over land in all directions. I learned that ice caps don't necessarily have to be at the tips of mountains. But as the planet gets warmer, so does the rate of ice melting. This is all important for several different reasons, most of which we won't have time to get into in this video. But one of the main reasons, which we'll get into later, is because glaciers hold a vast majority of frozen fresh water. And once it's melted, it either creates a lake or flows eventually into the ocean, which we'll get into in both of these figures. In this first one, we can see, well, it kind of just speaks for itself. In 1919, this is an image of a glacier in Switzerland, and we can see here all of this, it probably protrudes out here. All of this is glacier, right? And all these have snow caps, and there's more snow back here. And this area is very Arctic-like. In 2025, this is a picture in the same exact spot, but we can see there is no longer a glacier here. This is only 100 years. In geological timescale, this is nothing. This is a fraction of a blink of an eye. The glacier here is remaining here, and that's all that remains. There's no snow here. This is actually now what presumes to be some type of vegetation that wasn't there before. There's now, you can see where this area once stood now at the very bottom of the base is a lake, and there's probably some glacier milk coming through here. But again, this is dramatically a different environment. And this is simply because the planet has gotten warmer over these past 100 years or so, because again, we have this human enhanced effect on global warming. And over here on the right is a detailed image of the entire globe. If all the terrestrial ice melted, if that were to occur, the sea levels themselves would rise by 70 meters. And we can see this is not a map that I'm familiar with. It might have some similarities. As we can see here, parts of Australia is now under in the ocean. We can see the expansion of the Mediterranean Sea, creating new seas and expansion of what is there. We can see what parts of Russia were once melted are gone. We can see parts of Greenland are entirely melted, the ice sheet's gone. The bay here in northern Canada is expanded. Parts along the Atlantic coast of the Americas are now flooded. The Amazon River is enlarged. Here, the Mississippi Basin and all of Florida, gone. They don't exist anymore. And other finer details. Many islands are gone in this. Antarctica is now a chain of islands with some continents. Please note that there are several other equally important effects that occur as the planet warms up. We just don't have time to get to all of them in this video. I hope you guys enjoyed that. Please let me know what was the most interesting or shocking fact or tidbit that you learned. I hope everyone has a great day, and know that I love every single one of you. This is a safe space. And now, here are my sources.